Well, hi, and welcome to my shop, and thanks so much for coming and joining me here today. It's August 8th today, and I'm starting work on this fantastic radio. This is just a beautiful, beautiful cabinet on this radio. This radio is from around 1935, 36, something like that. Could be out by a few years. It's an early radio, and it's manufactured by a well-known Canadian company called Rogers. Maybe some people today would know, well, everybody would know Rogers as a TV cable company. In fact, the cable I use is from the Rogers Cable Company, and it's the same company, just many, many, many years later, having morphed into different businesses. So, okay, this may be the first time you've watched one of my videos, so I just want to tell you how I do this. I basically work an hour or so each morning. I turn on the cameras when I come in here and turn them off when I leave. I pretty much video everything I do, not quite everything. I don't do much editing, so it's almost like you're watching me live, and just about everything that happens in here gets on video. So the good and the bad. I've been doing this for a while, so I have some experience at it, but nevertheless, I find it easy to make mistakes. Sometimes what I think is going on is not what's going on, so what I'm saying really isn't true, and that sort of stuff happens. And in the worst case, I may intend to say the color red, and the word green will come out of my mouth, and I won't even know it. So, and I'm sure you've seen this happen to other people in live situations. So, when you watch my videos, you got to be thinking a little bit about them. So let's take a look at this radio. Let's take a good look at it. And like I say, this is a really nice looking radio. The speaker is up on top, which is unusual, and the grill cloth is hanging in there, but of course the speaker is sitting there ready to catch every piece of dirt and debris that should fall on it. And after this many years, I wouldn't be surprised if the speaker has dirt literally sitting on top of the cone in there. The cabinet here has just really grabbed me when I first saw this, because it not only is it curved, it curves right around, so it's a very curvy radio. Gives it a really neat look, and the wood here, this part is just beautiful. It's just fantastic. It looks like it's in 3 dimensions. It's a really, really beautiful radio, and the condition is surprisingly good. Now it looks to me like the trim down here has been painted once, but maybe not. But a lot of these radios, it's the trim and the corners that take the beatings, and the flat surfaces don't get much abuse over the years. So sometimes you can get a radio, and I think this is a good example, where you can make it look virtually like new just by repainting pieces like this. The whole top here is painted, which is unusual, but that means it'd be an easy thing to refinish this just with some paint. In fact, even a black magic marker is enough to make all this stuff disappear and hide away, and the radio is going to look just fantastic. So you've probably noticed by now some weird knob thing here. The owner has done this as just a matter of the only thing he had. So somehow the center knob here has disappeared, which is unfortunate, because a valuable part of all these radios are the knobs. The rest of them are here. These are wooden knobs because the radio is out of the 30s. It looks like it's slammed. It looks like the radio chassis is too far back, or this is too... No, I think it's on with a screw. Yeah, if you turn this, it's going to scratch the coating right underneath here right now. So I think the radio's not quite in the best of positions here. I'm just going to loosen that right now. Well, maybe I'm not. Not with this little screwdriver. Wow, it's really in there tight. Okay, I'm going to leave that for a little later. So we can't, well, I turn this a little bit and you can see the pointer does move. Good, so this is like a fine tuning and coarse tuning. That's how there's a geared system in here somehow. Very nice. And if we look at the band, the dial on this is fantastic. It's in perfect shape. I'm feeling for the print. Okay, the print is on the back side of the glass. There's nothing on the front at all. Last radio I had, half the print was on the front of the glass and the other half was on the back of the glass. So some of these radios, and I would warn anybody, some of these radios, the numbers in that are printed on the glass are so fragile that touching them in any way, they just come off like dust coming off. I've seen them that bad. And others will fool you. They seem to be pretty good, so you get in there with something to clean, a cloth or something, and halfway through cleaning you realize half the numbers are gone. And that ruins the radio, right? The radio to a large degree is this piece of glass. Certainly when the radio is not operating, what do you see? You see the fantastic piece of glass, and in this case this beautiful cabinet here. It sounded like it was loose there for a minute. I guess that's my imagination. Okay, so word on this is it works, but I've heard that before. This has been owned by the same person for a long time, I believe. This isn't a recent acquisition. An older gentleman, very nice guy. And I have the feeling this was being used up until somewhat recently, I think. So we're looking in the back here. I see it appears to have all of its tubes. Never seen this particular model of radio before. Now, a Rogers radio, early corporation, and still today, I'm pretty sure, very business-oriented group. What they decided to do was not only build radios, but they would manufacture vacuum tubes. But then they would manufacture they were big enough to do this, manufacture their own tubes for their own radios. So later on, when you bought a Rogers radio and you needed a new tube, because you'd have to buy a Rogers tube. Now in here, I believe there's only one Rogers tube left in here. Now you can see it here. You see it has a black coating on it? That's what Rogers was kind of famous for. They learned how to shield tubes by spraying a metal coating on the outside of them. But eventually people figured a couple other things out. One of them is we'll just put it in a metal sleeve. Put the whole tube inside of a metal sleeve. And so this idea only persisted in the mid-30s, maybe to the very early 40s, I'm not sure. And never, I'm sure they sold a lot of vacuum tubes. The problem is, today, those tubes are rare. Now, they have their own numbering system, but there are similar replacement tubes with a regular number and a regular North American type tube. And that's probably what's happened here, is the alternate tubes have been put in to replace the original Rogers tubes. How true? How can we be so sure? So see this one here, a 6Q7. See that the S came out of my mouth. Oops. Separate this. Should be able to. Not strong enough. I'll get rid of this bundle of wire here right now. Well. Okay, do that later. Easy things, not so easy. Let's take a look at the power cord here. So almost certainly this has been replaced. And I'm looking for cracks, exposed conductor, that kind of stuff. Any reason I wouldn't rely on this cord here in my bench while I'm working on the radio. Yeah, I'm going to get rid of this wire, that's for sure. Right here. Just looking the whole thing over. No, it's in very good shape. Doesn't seem to be strain relieved very well though. So we don't know what's going on under here. The owner of the radio contacted me originally and said there's a wire sticking out of the back of his radio and could I tell him what it was. And that conversation led to him bringing the radio here for a general fix-up, tune-up, and restoration. the wire he was asking about was this one, which I guessed was a ground wire, but he said no, he knew it wasn't a ground wire. So this, no doubt, this is the antenna wire. We don't know what this is, so we'll just leave it at that. It has the filter capacitor here, but it also has a field coil speaker. See, here's the output transformer, but here's another coil right here. This large coil generates the magnetism needed for the speaker to operate, because back at this time, mid-30s, they couldn't build permanent magnets with enough strength to do the job. Shortly after this, though, permanent magnets were improved a lot, and speakers began to have permanent magnets, and they stopped doing this field coil thing. When you see a speaker with a coil like this on it, watch out. That's telling you that there's a couple hundred volts going through this coil, and you could find that out with your hand. And a lot of people think speakers, a couple volts, no more than that. That's not true. This has the output transformer on it too, so plate voltage is coming up here. So there's a couple hundred volts here, a couple hundred volts on this coil. You just don't want to be doing this kind of thing when it's operating. And the radio will not operate at all without the speaker. You have to have this speaker or one identical or extremely similar to it, and it's got to be wired in right. Not likely to happen. So in the modern equipment, say from the 70s forward, I would call that modern, all speakers were 4, 6, 8, 10 ohms, and few had their output transformer on them. Few even needed it because transistorized equipment doesn't require that technique of getting the signal out of the radio, out of a tube radio. So you might not be familiar with this. That's what I'm getting to. You might think, well, it's just like any other thing with a speaker. No. The best move we can make with this is withdraw it from the cabinet. And it looks like, it looks tricky. The speaker, no doubt, is bolted up to the top. I think I see some screws up on top here. It looks like the speaker has to come out before you pull out the chassis. That's what it looks like. So I think I'm going to do that because I do want to get a look at it. Now look at these weird decorative screws they've put up here. I don't have a screwdriver that looks like that, but my guess is you don't need it. And is this a nut and bolt? Yes, it's a nut and bolt arrangement. Let's try this. Okay, need a big screwdriver to do it, big wide one. See if I just dropped a washer or something down into the radio, and it's lost in there. Okay. No washer. Very stiff. These wires are very, very stiff. That's something worth checking. We can have a lot of leverage. You can swing this up. It doesn't feel like much in your hand. Meanwhile, you're putting a lot of tension on here. You can crack the insulation on these wires. Now these are cloth-covered rubber wires. They can actually take a huge amount of that. You can crack these pretty badly, and they still won't short. But better to just leave it in its native position as much as possible and not strain it or stress it, or well, you'll just have more to do. I'm guessing this speaker is going to drop off here too at some point. can't say I've seen many radios with the speaker up on the top like this, especially these wooden ones. So that's an unusual arrangement. That time the washer came out. Oh, there it is. It's a lock washer. Probably the lock washer is probably still stuck up here. Now, there's just a few parts to these old radios that are, if they don't work, the radio is kind of finished. One of them is the speaker that I'm taking out right now. There's not many parts like that. Speaker. Yeah. This isn't working. Power transformer. Obviously the dial glass. But you know what? There's a company that makes dial glass. New dial glass. Let me put this huge screwdriver to it here. And I've ordered a few over the years. People have had radios with cracked dial glass. And this company produces, they are beautiful. And they look exactly, they look exactly like they should. How come it didn't move at all? There's not a lot of room in there. Let's take a little look at what I made done. I'm going to jump the gun here. What's that? What's this thing? Big spring on it. Well, the clearance is minimal. It looks to me like I'd have to extract the screws out the top to get the speaker then to just slide out like this. Because I don't think I can drop it. Why didn't it drop? What's holding it? It could be some kind of rubber. There it goes. Okay, now it's dropped. And I can't get it out. Now, you know, these screws are sticking down. They're ready to destroy the cone. I should drag the speaker across them by accident. Can we get them out? It's a job for the Swedish fish knife. Or is it a Finnish fish knife? It's not coming out. What is holding it in? This is basically challenge number 1. Probably don't have to take it right out. Now, these are machine screws, but they are threaded into the wood a little bit. I gotta guess that those are free of the speaker now. Okay, speaker, just slide on out. Slide on out. Something catching it? Oh, the speaker wire is clipped here. Looks like Green Roberts. So you know it's a Canadian built radio and it's got these square-headed screws. If you're Canadian, you've been seeing these all your life, you don't think anything of it. But if you're in other parts of the world, you've never seen a screw with a square head. See, I got a square screwdriver. It's a Canadian thing. I don't know how popular it is in the world. Roberts screwdriver. Here he is. Okay, well, actually the material on top looks pretty pretty good. I don't think any dirt has gotten through. There's the big coil. There's a tiny little coil inside here that's in the magnetic field, and that's the part that coil gets moved, and the coil is attached to the cone, so the cone moves too. That's a cone. Not a very big speaker. Looks good though. Looks to be in pretty good shape. Fantastic. Okay, let me put this into a safe zone here. Now, getting what I'm going to do with all this stuff. So I'm going to stop the video for a moment. I'm going to drink a little bit of coffee. I'm going to put these screws back in on here so they are where they should be and are not lost. And then we're going to take the chassis out and see what we see then. Okay, let's see what's holding this radio in. Just take a peek here. Oh! My gosh. Great big bolts. So they're just barely below the feet here. Yikes. There's a foot right there. Yikes. Hey, there's some information under there. 6-tube, 2-band radio, tube locations. Okay, it looks like one of these. This is a difficult radio to hold on to. This is just as loose as can be here. Oh my, this is a lag bolt. No, it's a machine bolt. Okay, get the rest of these out. I don't know what's under there. So I just leave one edge of the radio over the edge of my bench rather. These are major bolts. These are original? I think they must be. So while I'm doing this, we can look at some of the stickers on the back here. Caution. What caution? To obtain maximum performance with this receiver, replace tubes as required with only genuine Rogers tubes. So it's a sales pitch. That one. There's a sticker over here from the Canadian Standards Association, or the power in Ontario, the main power company at that time. It would authorize these units to be plugged into the electric system. So they had to have an authorization. And I'm surprised that it doesn't call for a license. I think you had to have a license, I'm not sure now, right up into the Second World War. You have to get a license from His Majesty. Big washer's missing on this one. So clearly I'm not the first guy to do this. Now we have to get these knobs off. So let's just see, is this too big? A small screwdriver. Now where's my medium screwdriver? Son of a gun. I must have wandered off in the house with it. Well, we'll give this guy a try, but I'm going to have to probably... Yeah, I think it's too small. Yeah, I can't get the leverage on it. Okay, gotta find the right screwdriver somewhere in my house. Okay, great. So, it's out of my garage just now. Out in my garage I have a temporary table set up for yesterday. Yesterday I had 14 radios on that table and sold them all off to a store in Toronto, like a used store. Oh, this knob is very, very... something going on here. Not with a knob. This is a replacement. I'm pretty sure. See how this shaft is solid? This one's not solid. And I think this is a replacement, and probably the shaft, you know, was much longer originally, and they cut it off to make it fit here. But something's loose, that's for sure. Okay. So I had this table with 14 radios on it, and the idea was it's a store operation in Toronto. This is loose. They come up, they bring up a bunch of radios for me to work on, little radios, for them to sell their own stuff, and I tickled them with my own radios, and off they went. In the meantime, I took the ones I have here now, which at some point, this is just too big. At some point, will be in here, and store them all away, so the table's empty. It's just just some boards on it, you know. It's a very temporary thing. Man, we just went out there just now, and the table's full. What? Oh my gosh! Break the screwdriver. Yeah, one of my buddies came by and, without telling me, dropped off some interesting stuff. Keep me busy. He didn't realize. Just yesterday, I got enough stuff to keep me busy for months. And then I have my own radios I want to get in here. Let's try this again. Oh my gosh! This is a silly situation. Come up this way. I'm not gonna get the clearance. Let's try this one again. Just getting the knobs off is a big deal here. So when I first walked out and I saw this table full of stuff, I had kind of, I don't know what to call it, a moment of cognitive dissonance. That's what it is. I couldn't believe what I was seeing until I realized. Okay, well, you know what? This is just craziness here. Maybe I've got it now. You know, you can stick a screwdriver into something like this and the screwdriver will bite, but it's not in the screw. It's gone down beside the screw or something like that. When you can start twisting on it, bad things can happen. Oh, I think that was in. Okay, enough of that. What's going on with that screw? Nothing. Okay. Now we're ready. Drag this guy out the back. Now, once in a while there are complications to removing a radio from the back of the cabinet. There can be interference up at the top here, because in the front of the radio has a large plate. You can see it here. This one looks free and clear though. It looks like it's no big deal. The thing about it is, you're taking one of these things out, they're really heavy, you get it halfway out, it gets caught on something, now you're just seconds away from doing some damage to the radio because it's heavy and you're going to want to rush, and you're going to yank, and next thing you know, something bad will have happened. Not in this case though. In the worst case, some of these radios, not these radios, some radios, the dial plate and glass are in the cabinet and they're not on the chassis. So when you pull the chassis out, the pointer stays behind on the plate. It's really it's so easy to do some damage. Okay, it's going to sit here. No, let's go a little further. I don't want to do two things. Drop this on the floor and scratch this cabinet. Either one of those are bad. Let's go a little further forward. Okay, gotta get this out of here. Okay. off to the safe zone, but first we take a peek inside. There's nothing in there to see. There's no written information, but you see there is another grill cloth on the top. So there's actually two grill cloths. There's a grill cloth and then the speaker protector. So the guys who designed this radio realized putting a speaker facing up is going to be a catch-all for dirt and crime. Okay, let's look at the top of the radio, see what we can see here. Anything that might catch our interest. Maybe we'll figure out what the mystery wire is too. Here, let's just take a little bit of an elevated view of things. So, what do we got here? We got two big filter capacitors. You've got tubes that I would question whether they're the right tube, but they probably are. It's not likely they're the wrong tube. We've got this strange thing here. This deal, I believe this is a brake. And what it's doing is it's applying some pressure on this set of plates. So when you turn the dial to tune the radio, where's that? Right here. Ooh. Oh, that sounds just terrible. There's no string in this. So this has a slip clutch plate right here. And the idea is, you know, one of the difficulties with these radios is what happens when you reach the limit. When you get to the end, are you going to break something, or is something going to give? Well, they've arranged it so something gives. The string slips under the knob, or something gives, so you can't break it. In this case, there's a slip clutch arrangement here. Why does it sound like this? Jeepers. I'm not sure. That's terrible. I mean, you know, what's one of the big deals with a radio is the feel of the tuning knob. This one is like the worst feeling thing I've ever. It's clunky. I don't know. What would make it like that? But in any case, this part here, the spring-loaded plunger pushing basically a broom on the surface of the plates here to give to stabilize things, I guess. Look at this. This has a cap in it. Gotta open that up, probably. I don't know why I would. Never seen a cap on the top of a. Look at the size of that transformer. It's big because this radio will run on 25 cycles. So you have a great big transformer. It should mean that this runs even cooler on 60 cycles, which of course is the way the power is today. Did you know there was once a DC power distribution system in downtown Toronto? If you're from Toronto, you could think of streets like Bay Street and Queen Street and things around Old City Hall that were electrified, and there was an Edison DC distribution system set up. Don't know what the voltage was, probably 500 volts, I don't know though, buried in the streets. And I've seen it because of the work I used to do. Sometimes I would arrive at an excavation in the road somewhere in downtown Toronto, and you look down in it and they'd say, "What's that thing?" It'd be a joint, a T connection box where the cable's coming through and you want to tap off to a building. They had these weird big boxes. They looked like automobile differentials. They had that shape to it, and just buried in the ground with steel pipes coming in all directions. And inside the steel pipe is the actual cabling. Conductors, they used a piece of rope. They would spiral around the conductor and then shove it up into the steel pipe, and then the rope would keep the conductor in the middle, and then they'd flow tar or some black icky compound down in there to get rid of all the air and block moisture from getting in. And that's the Edison cable system. They're about 20 feet long, 20-30 feet long, and then jointed every 20-30 feet, whatever it was, in boxes, and all filled with compound. And it was the first successful underground distribution system. It was basically a piping system to keep water out with the cables inside. And that stuff still exists in downtown Toronto. It's still down there. Of course, it's been chopped up and half obliterated by various other excavations, the things in the way, and you just cut it out and get rid of it. So history under the streets. Direct current. Okay, enough of yapping. Let's see about these tubes being correct. Let's not. Let's look underneath. I want to look underneath. There's no bottom plate here. So to tip this up on its side, I'm going to go with putting this heavy part down for sure. Not have it up in the air, because that probably 2/3 of the weight of this radio is in that transformer. Ay, 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 he says. Well, I'm ay, 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 because the look of the wires. Oh my gosh, look at this. This is what it looks like outside. Pretty inviting. That's what it looks like inside. And look at, can you see this? See that? I'll get the close-up camera going in a minute. Let's just say if I had plugged this in, a price might have been paid for that move. Okay, so I see a few other scary things. This coil looks like it has been on fire. It's all blackened in here. What is this rubber? What's this rubber piece doing here? I don't know why they would have that. It appears to be knocked off, but not necessarily. See, this one's on a bit of an angle too. None of this you would ever want to move. Like, you wouldn't want to move these in any way, shape, or form, because the radio's been set up with these on. If we look down here, again, we'll look with the close-up camera. This compound has poured down out of the transformer. Oh, you can hear stuff. Hey, look at that. Found it. Stuff has leaked out of this transformer, which means almost certainly the transformer has been overheated. Okay, another interesting thing about this radio is it has these batteries. This is a battery. There's another one right here. These are little batteries. So basically, this is probably zinc. I don't know though. And there's a carbon button in the middle. And then there's a rubber seal. And then inside here would be some liquid, some water of some sort, moisture anyway. And you get battery action between the carbon and the zinc, or whatever this metal is, because of the difference in the electromotive force inherent in those materials. They have different electromotive force. I won't get into how batteries work, but unfortunate thing about this is these aren't going to be producing any voltage anymore. And we're going to check that. Well, what I have done in the past, and I'm not saying this is a good idea, it's just something I've done, I've stuck them in water, left them in water, tried to get some water to penetrate. You know, the seal here is probably shot. Water to get inside again, any amount of water, and the battery action will start. And you might be saying right now, battery? What's a battery doing in these radios? And I'll tell you what it is. It's a cheap, easy solution to biasing tubes. The battery produces around a volt probably, if it's working, and the volt is enough bias on the radio, and the audio signal or whatever signal is going through the tube to be amplified was right through the battery, like it's not there. So extremely convenient, but there's a reason why they're not used anymore, because they would go dead. Any voltage. I'd be stunned if this shows anything at all. Well, okay, so it's teeny tiny. See it going down and bleeding away what little charge was sitting on here. Now if I remove this and count to 7, 1, 2, 7, and touch it again, you'll see the voltage will have returned. You liar. Yeah, there it is. Kinda. It just continues down. The other one's going to be the same. Now what do we do about this? Well, a couple things. One is you ignore them. Just leave them in there and ignore them. I'm not sure that's a good idea. Replace them? Replace them with what? This one's got a little more juice to it. It's jumping around here. Got up to 0.1 there at one point. Or is that my finger? That's my finger. Okay, causing battery action against the metal that I'm touching and the other metals. Yeah, I've become the electrolyte. Well, we could try soaking them, but of course, how long is that going to work? And what happens if you don't have them in the radio? And, another option is you just short these out. Just short them right out and say goodbye to the bias on the tube. You probably will get distortion in the audio or some other undesirable effect. I'll leave these out for now. I just put them over here. Maybe I'll soak them in water. We'll see what happens. Okay, what else can we see here with the long-range camera? We see, this is the bottom of the filter capacitor here. The other big filter capacitor was way up here. One of them could be a bypass capacitor. We won't know until we're looking at the schematic. So these capacitors are very unreliable. These molded capacitors are an attempt at putting a plastic shell over a wax paper capacitor. Maybe there's no wax involved anymore, but basically it's the same thing with a plastic shell over top. And the idea is to make it more impervious to moisture, and maybe it did, but not for 60 years. Plus, if these are inexpensive or cheap capacitors, inside the paper isn't as clean as it could be, that they made the capacitor, the paper can have contamination in it. It's really expensive to, the last 10% is always, very, very expensive. Same thing with cleaning paper for capacitors. So, but these ones have a bad reputation. There's another one here that has a bad reputation. This style capacitor also, these are all old. They have a bad reputation. They're old. Do I have a bad reputation? I hope not. So this burned up thing here, this really worries me. That's not a good thing to see. This would have produced a prodigious amount of smoke, I think. You would have smelled this. That might be the last time the radio was operated. This kind of thing happens either because of slow degradation of a component like a capacitor, or a sudden failure of a capacitor, short circuit on the capacitor, heavy current flows, something else is going to give up, like a fuse, and these wire coils are high on the list. With something like this damaged in a radio of this sort, it's not going to work, or it may not work on one band, or in fact, the wire may still be intact in here. It may all still work just fine. It may have gotten overheated, but the wire itself is still there. See lots of older capacitors up here. What's the count? 1, 2, 3, 4, 5, 6, 7, 8, probably 2 more I don't know about yet. About 10 capacitors. All of them need to be changed out. Now we got lots of old resistors in here too. Everything's old. Now there's a good chance that they've gone off, but there's also a good chance they haven't. It's an individual kind of thing. So I am just assessing what it is I am going to be doing with this radio. Let's take a close-up look. Got a couple things there. I'm going to start right with this. Now, okay, so the automatic focus is on this camera. I'm gonna nullify that because it's going to cause problems. So just bear with me. I'm not going to stop the video. I'm just going to take a moment here to call up the dialog box. You can imagine what I'm doing here on my computer, and we're going to turn off autofocus, and we're going to make it just a little bit closer. There. Let's try that. That's an ugly thing we're looking at there, isn't it? What is going on with that? Yeah, I don't know exactly what's going on with this material, but just look. There's the original wire. I think we know what's going on with that. And then it's jointed here to the beautiful wire. So we'll have to clean all this up. I guess the person who did this, they didn't want to break into this, and there's good reasons for not breaking into this. So when the radios get this old, these wires can get very stiff, and doing anything with them, wow. Yeah, this is scary stuff to work on. As soon as you start working on it, the insulation begins breaking and breaking and breaking. The key thing, let's look at the goop coming out of the, see this black tar tongue is hanging downwards. Oh, that stuff's as hard as can be. Well, not when you heat it up, it's not hard. Well, that's definitely a sign of overheating, and the same compound in some cases flows up the wires and stiffens them like crazy. And it looks like that's what's happened here. These don't feel terribly stiff. This one does. That's like a pipe. So good to be, you got to figure these things out early on. How stiff are the wires in the radio you're working on? Let's see, these rubbery ones are nice. These are very nice. The cloth covered wires actually do very well. This one's stiff. Stiff. Some wire bundled up here. Going out. Where's that going? Hey, is this the mysterious black wire? It is. So here's the two wires hanging out the back of the radio. They're coming from the front here. They're knotted. Then where? Okay, this is something to sort out a little bit down the road. But that gives a better idea what those wires are. I still think it's a ground and an antenna. Antenna. Ground. But can't be sure. Okay, we'll use the close-up camera. We'll just look around here. What's that resistor doing there? Looks like it's not soldered in on the right-hand side, but I think it is. I think it went through the hole and comes up onto the terminal here. Of course, it's soldered in. A little porthole behind it in the chassis. Must be sometimes some wires go out that. That's a special hole there that's designed for wires to go through. This looks like a whole setup for some wire to come out and go out that hole. A hole here, another one there. They look like they're protected. You know what, maybe they're just a rivet. It's just an ordinary rivet. And it's just a rivet holding this terminal strip. Nothing more. Okay, enough of that. Look at that, that's a resistor, that black thing. Yeah, look at that thing. Yikes. So while working on this radio, you can't be moving wires out of the way, at least not much, or they're going to break. When this radio was built, they would have used the soldering iron like a size of a small baseball bat to try to build this thing. And they'd be working in a factory with poor lighting, almost certainly relying on windows for lighting. And little did they think somebody would be looking at it in 2022. That'd be an unimaginable thing that this radio would be around. There's a really nice looking switch there. Let me see if I can operate it here. Stick a knob on. Okay, using a wrench, like this, on one of these is something you need to do with great care, because the wrench is giving you tremendous strength as opposed to a little knob. So you can push things past their limit. Let's see what happens now when I turn it this way. Well, oh, that's the end there. Oh, this is a two-bander. So the switch only goes two positions, I would say. Now, didn't I see a phono thing on the back? Did I? No. No, there's no, that's another radio. Okay, switch moves. Let's go look at, what was that other interesting thing I wanted to check? How did I forget this? Oh, the burned coil. Oh yeah, it's right. it's the easiest thing to see in this radio. So I'm looking at the wire now. The wire doesn't seem to be burned. Maybe it's not burned. Maybe this ring has. Oh, the ring is a coil. Oh, this ring is what overheated. Oh, don't touch it anymore. Don't touch it. The wires, the little tiny thin wires. Hey, don't touch it. Oh boy. It looks like one is broken there, I can see. Oh boy, okay. Well, this is, depends. This could be a bad scene here. Oh boy. So the heat, so the whatever burned this coil, the electricity is traveling through other things to get there. But probably this is the main cookout, so that's what happened there. Looks like now the wires are insulated with a thin coating of shellac, like these ones here. They're insulated. But you heat it up enough, the insulation burns away. You can see these little wires look like copper. So chance of a short, oh my gosh, it's almost 100%. And then we have no idea what actually happened in the coil. How much of that is just clumped up copper now. This must have produced a lot of smoke. It'd be a frightening amount of smoke coming out of the radio. Certainly, you plug the radio in and turn it on, there's a good chance this thing will just smoke right out again if it's still able to conduct electricity. So one of the things I like to do with these radios is get them operating as soon as possible with as little effort on my part as possible. And the reason for that is once the radio is operating, even to any lousy degree, you've proven a whole bunch of things to be. That's cracked open there, isn't it? Once the radio is operating, you've proven a whole bunch of components to be good enough. And while you work on it, you can continually check in and see if it's still working or not. If it's not working, if you can't turn it on like this one, then you work away on it. As far as you know, you're making a mess of things because you can't test. You can't test until the primary issue is resolved. So we look at this coil again. This coil didn't burn up because it chose to burn up. It burned up because somebody else in the chain gave up their ghost, and it's almost certainly a capacitor. Not necessarily, but almost certainly a capacitor. I don't even see any around here. Where have all the capacitors gone? They vaporized. They're gone. Okay. Another thing I found about doing this kind of work, and this is just generally true all the time of everything, the longer you look, the more you see. So, not to rush on these initial inspections, and this looking thing goes on forever. As you're working on the radio, you continue to look at it, you look more closely here and there. You still make visual discoveries as you work away on them. You can't, I couldn't tell you I've seen everything I need to see yet. How do I know? But I've certainly seen enough here to make me a little bit nervous about this radio. Okay, and I'll just talk off the top of my head here as I'm doing. So repair plan for this radio. Well, there's a couple questions here. Should we just go right at this coil right away? Maybe prove it's still there and it still conducts. Depends on the schematic, quality of the schematic. But that's one option. One option is go at the coil, see what you can do about that right away. If the coil itself is shot, I have to replace it. How am I going to do that? How the heck am I going to do that? Wind my own coil? That's not easy. I could see enough of this coil that I believe it's been wrapped or wound in a very special way. You can think of a winding, you just keep winding the wire like this, so it's parallel to the wire beside it. And that parallelness ends up building up some capacity in it somehow. If you could make them crossed like this, then they would have no interaction. But how are you going to wind a coil with wires going in these directions? Well, turns out if you can do this, you can get most of the effect, or get rid of most of the effect. Lower the capacitance of the coil. I warn you, I may be getting this story wrong. Okay, so some coils like this one, this big one, they're just wound side by side. This one looks like it's wound especially in a special way. And I'm not about to be able to replace this coil. So that's why this is a serious situation. We don't know for sure that this coil is used all the time. There's two bands. I see a fine wire coil here and a heavy wire coil here, and I see the same pattern over here. Fine wire and heavy wire. So this could be one band, this could be the other band. So half the radio may work, the other half not work. Or one band may work, one band not, under these conditions. I think part of the repair process too would be, even if I don't attack this, to try to figure out logically how did it get into this shape, and then see what actions I can take to ensure it won't continue burning it when I first fire up this radio. So that would be looking for a faulted capacitor. Beyond that, beyond a shorted capacitor, it's a stretch. I'm just looking at the radio here. I haven't studied the schematic, but you could get a short inside a vacuum tube that could potentially do something like this. You could get a general short, two wires shorting out, but that's not very likely to have happened. This is the issue with this radio, I think. At this point, that's the issue. This is not a big deal compared to this. This is a big deal. This is a survival issue for the radio. The batteries here, again, there's various ways to get around this. In one case, I actually stuck new batteries. They're just a regular, those thin batteries you put in, for crying out loud, hearing aid type batteries, little flat ones. I was able to put a couple into a radio, and there's no current draw on these batteries. They're basically putting a voltage or a pressure on a piece of wire that simply goes into a vacuum tube and nowhere. Sits in the vacuum tube, doesn't actually go anywhere. So there's no draw on these. Okay, I'm going to stop, have a coffee, think a little more, but I think we're nearing the end of today's video here. Didn't take me long to realize what I have to do next. To use the chart here for the tube types, and see 75M, and that's very clearly, the M marks it. These are all Rogers tubes, 41M, 75M, 6K7, M, 6A7. So maybe you could put a regular of these two tubes in there. Look at that radio again. It's only got one original tube in it. This is a Rogers tube. You see, I guess, a few years went by, this idea disappeared, this metal idea came in place of it. I can see that's a 6A8, and on the chart it's a 6A7. That's not so good. Another way to burn up a coil or do some damage to a radio is put the wrong tubes in it. They're not swappable like that. Not that I know of, but I don't know. A 6A7M may be the same as a 6A8 of this style. I don't know. I have to look into these things. Something burned that coil up. Okay, so this tube is a 6Q7. Now, so see, we can't even compare. This says 75M. So it could be the same because Rogers had their own numbering. Just to, again, try to make sure people only if you got a 75M to put in my radio, that's what they would ask for. Even though perhaps this tube, what is it again? What is it? Let's get it out. Only one tube at a time, or I get confused. 6Q7. Why did I even say that? So I have to study a chart. I know where there's a chart that will tell me this tube is the same as this tube. Or maybe. This doesn't look right either. This looks way off. Let's see. Now, sometimes the old radios, what people do, and I'm not saying this happened with this radio, people like to see tubes in the socket, so they just got some tubes, they shove them in. Then they hand me the radio. 6K6. This is incredibly, I was going to say it's incredibly wrong, but that's not necessarily true. 41M. Well, we're going to have to just do some investigations here. 6K6, eh? This one, this came out pretty easy. Not gripped in there, right? It's a Rogers tube. This is probably a 2x3. Yeah, 2x3. You can see that it's got room for two pieces in here, but only has one. And that's its brother over here. Okay, they gotta work in a pair. Come on, bro. There we go. This is a... Oh no. This is a tube with no label. You have to look at tubes very, very, very carefully. Sometimes the vestiges of the label still remain, and just enough that you can read it. Boy, oh boy. Oh, there it is. I see it. 2x3. 2x3. On the top here, 2x3. So it's the right tubes. These are the right tubes. So these are the rectifier tubes. And in most cases, they would have both sides in one tube. Why Rogers did this, I don't know. Perhaps they thought it was better reliability. See how darkened it is up here at the top? It's not particularly good. This one's got no darkening at all. Now, this down here is different. This is supposed to look like that, shiny metal on the inside of the tube, but this not so much. So you see, it's right above the element or the functional part of the tube. A little hard to see in there, isn't it? There we are. Black. What's that mean? I don't know. What would that black be? I don't know. I could take guesses, but I don't know. Okay, that's the story. Question mark on the vacuum tubes. Okay, I'm gonna look into that a little further. Okay, so I'm on a website of a small Canadian company that sells capacitors. I buy capacitors from this company, Just Radios. They are nice enough to have quite a bit of interesting information on their website, and I suggest you avail yourself of it, especially if there's stuff around the hot chassis problem for some radios. Not the one I've got on my bench, but other smaller radios. Smaller radios can be more dangerous. So here's the whole story. You can go to this website, justradios.com, type m.html, and you can read this yourself in detail. I just want to look at the chart here. So here's the chart. So one of the tubes is 75M. It has a 6Q7 in it. So let's see if we can find 75M, 6Q7. There we are. And 6Q7G. G stands for glass. Okay. So you see, Rogers was really making 6Q7s. They put their own name on it. Little sneaky people. 41M right beside it, and the replacement is 6K6, and that's what's in the radio. Oh, we're doing good so far. Now we want to look at this 6A8, 6A7. Is the 6A7 listed in here? 6A7, and it can be replaced with a 6A8, G with a shield, or GT with a shield. So 6A8 is a metal tube. The G stands for glass tube. So even though, by the way, it says metal tube, it's glass inside the metal. That's how it's gas tight. So okay, so this radio's got substitutes in it, but they are correct. And one original tube still. So this information is hard to find, by the way. I mean, the reason it's on this website is because Just Radios is located in Toronto, Canada. And this is a typical issue around here. A lot of people would have these Rogers radios, like the one in front of me. And this information's a little bit obscure. So thank you very much, Just Radios. And let's go back and look at this radio some more. Okay, so it seems to me I have to do a few things to this radio before attempting to power it up, for fear of burning out the last bit of life in that coil that's in there. Next step then logically would be study the schematic, focus in on that burned coil, try to understand as much about it as possible, perform some kind of tests maybe to prove it's there or it's not there. I mean, it may look all burned up, but it may still be working. Cross your fingers that's the case. And if not, then I don't know really what to do about it. I don't think I can wind a coil. I mean, maybe I can get something, do something to make the radio limp, but I don't, the only way to really make it work, perform the way it's meant to perform, would be to replace the entire coil. And that really amounts to getting another one of these radios. So that's the problem. And you're going to get another one of these radios. What are you going to do? Take the coil out of it and ruin the other radio? I mean, it's a problem. And look, it's hard to see it. Right here where my finger is more of that black compound that's leaked out of this transformer. Do you think this cap is meant to refill the compound? Or maybe when they built the transformer, the last thing they do is this cap is off. They pour hot liquid black icky compound in there and then put the cap on. That's probably how they did it. Okay, I really think that's it for today. Tomorrow we will look more closely at the coil. I think is really the starting point in this radio. Thanks a lot for watching, and I hope you have a great day. See ya.